In this recap session, we are refreshing our memory on function analysis. This topic allows you to get a general idea of the behavior of a function without having access to its graph. We identify specific points and regions by looking at the function, its first and second derivatives, and linking them to their graphical interpretation. Let's take the cosine of x as an example. Because we already know how its graph looks like, we can always check our results. And to write down our analysis in a structured way, we collect our results in table form. Step 1 is to identify special functions in our function itself. In particular, finding the value at x is equal to 0, and conversely find the values for x where our function output is 0. Filling in x is equal to 0 in the cosine, we immediately get 1. And we know that the cosine returns 0 for x is equal to pi over 2. But because it is a periodic function, it will also be 0 for any multiple of pi over 2. Additionally, the cosine is minus 1 for minus pi and pi. Now, because a continuous function cannot switch sign without first being 0, we know that in the interval between minus pi and minus pi over 2, the function will be negative. Between minus pi over 2 and plus pi over 2, positive, and between pi over 2 and pi, it will again return a negative number. So we already have an idea of the sign of our function in this interval. Step 2 is to consider the derivative of our function. Recall that a derivative represents the slope of the function at any point. A positive derivative means a positive slope. A negative derivative means a negative slope. And right in between, when the derivative is 0, the function reaches a maximum or minimum. The derivative of the cosine of x is minus the sine of x, which we know to be 0 at x is equal to 0. Filling in some values, we can find that for x between minus pi and 0, the derivative is positive, and thus our function increases. For x between 0 and plus pi, minus the sine is negative, and thus our function decreases in this interval. So now we already know the regions in which our function is positive and negative, and that it increases from minus pi, reaches a maximum at 0, namely 1, and then decreases again until it hits plus pi. The third and final step is to get an idea of the curvature of our function. By looking at the second derivative, we can determine whether the function is convex for a positive second derivative or concave for a negative second derivative. When it is exactly 0, the function changes from convex to concave. The second derivative of the cosine of x is minus the cosine of x. This function is again 0 at minus pi over 2 and plus pi over 2. For x smaller than minus pi over 2, minus the cosine is a positive number, and thus the function here will be convex. And likewise for values larger than plus pi over 2. Between these two boundaries, the second derivative will be negative, and thus the function itself will be concave in this interval. Now we can compare what we have found with the actual function of the cosine of x. We see that indeed it reaches the values minus 1, 0, 1, 0, and minus 1 at the given values for x. We can also identify the regions where it is positive or negative. We see that it increases in the first half of the interval, reaches a maximum at 0, and then decreases again, exactly as we had found. Looking at the curvature, we indeed see that it starts out convex, switches to concave exactly where it crosses the x-axis, and then becomes convex again at pi over 2, also exactly what we found. This shows the strength of function analysis. Now, if you want more practice on more difficult functions, you can visit the channel for more videos. And as always, thank you for watching, and I will see you in the next one.